Hello, I'm Matt.
I'm Joe.
And I'm Anthony.
And this is our Lab 2 video. Important concepts in this part of the lab include irradiance and source types. Irradiance is a measure of radiant flux per unit target area. The two main source types include isotropic and Lambertian. In this part of the lab, we measured the irradiance of 3 different sources as a function of their angular distribution. We did this by rotating our detector on a mechanical rotating rail. With the exception of our tungsten bulb, we found that each of the sources behaved like Lambertian sources. This is because the ratio between the distance to the source and the size of the source itself is large. The result from our tungsten bulb was different because the apparent size of our source changed with angle.
Important concepts in this section include the differences between illuminance, irradiance, power efficiency, and how they relate to multiple sources. So as we can see here, the irradiance is highest for the incandescent bulb at about 5.3 milliwatts, whereas it's closer to 1 milliwatt for the fluorescent bulb and the LED. So unlike the irradiance, the illuminance was pretty similar for all 3 light sources. For the fluorescent, LED, and incandescent, they were all within 3 lumens of each other. This is important because, as we can see, the LED in the power efficiency section does much better than the other 2, which implies that it has better luminous efficiency as well, achieving relatively the same amount of lumens with almost 3 times as less power. So, in comparison to my prior knowledge, I would say this matched up pretty well. The only thing that kind of surprised me was that the fluorescent bulbs were actually less efficient, but people generally choose them because they use less overall power. I thought that was kind of interesting.
The important concepts in this part of the lab include the distinction between band, line, and blackbody sources. Blackbody sources emit light over a broad range of wavelengths such that their emission spectrum is a continuum, while band sources emit light over smaller parts of the visible spectrum. Line sources, however, are sources that have very narrow and often multiple across the visible spectrum. These concepts are important in knowing what source to use in certain application spaces, from signal processing to spectral calibration. From the ocean optics spectrometer data, we can see that band sources make great calibration sources due to their very delta-like spectral features. Unfortunately for the last part of the lab, the optical pyrometer was not working. Therefore, we shall explain how it works. The optical pyrometer compares the brightness produced by the radiation of an object whose temperature is to be measured with that of a reference temperature. This reference temperature is produced by a lamp whose brightness can be adjusted until its intensity becomes equal to the brightness of the source object. The change in color, with growth in temperature, determines the temperature of the object being measured.